Okay, so that was the demo of how to set up DP4DS distribution. Now, for those of us in this class now, does everybody see now how to hand in your homework with courses? Let me, yeah, question?
I was saying, where did the numbers come in?
Yeah, let me explain how that works, how that's going to work in this class. Okay, so everybody has a 2-digit number, right? So what you need to do is, if we look at, here, let's go to the course web page and look at assignment 1. So now in this course, the way we're going to hand in homeworks is everybody has been assigned a 2-digit number. So if we look at assignment 1, it has, each assignment is going to tell you exactly which files need to be modified and hand in with your assignment. In this case, it's shapemain.cpp, circle.cpp, etc., all the way down to righttriangle.cpp. So there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 different files that need to be modified. Now here's the way to do this. And this is important, because if you don't do it this way, if you try to do some shortcuts, it won't work. First of all, first of all, get your programs written and compiled and working in DP4DS distribution without any 2-digit number at all. Are you with me? In other words, modify these files as you need to complete, to get it to run, and compile it and run it. And by the way, you guys, if you hand in a project that does not compile, it's impossible for us to test it and to debug it and then to test it. So if you hand in a program that doesn't compile, it's automatic half credit. Okay, so if you just hand it in but it doesn't compile, we don't have time to look at it. It'll just be half credit. So get it to compile. That's number 1. Okay, and then just as a rule, you should never hand in anything that doesn't compile. Right now. And so after you get the program to compile and you get it all debugged to your satisfaction, then what you should do is go into your DP4DS distribution outside of NetBeans. In other words, don't, quit NetBeans. Just quit NetBeans. Go and depending on your operating system, with a Finder or whatever with Windows, and duplicate each one of those files that you're supposed to hand in. Duplicate them and take them out of DP4DS distribution and put them somewhere else in another directory somewhere. All right? And then in your operating system, prepend your 2-digit number to each one of those files. And that's what you hand in on courses. And what my software will do is my scripts are programmed to take the files that you hand in and to strip off those 2-digit and to see who, so that we can see whose, files they are. Strip off those 2-digit numbers and test them. But it's a script; it all happens automatically. So it's important that you follow. It's important that they're named exactly the way they are named here, and that you make a copy of them, put them somewhere else, prepend the 2-digit numbers on the name, and that's what you hand in. Okay. Is everybody clear on this? Yeah.
So it's just the, it is both. So it's the source files and some header files?
Yeah, yes. Each assignment will tell you exactly which files to hand in. And you hand them in that way. Yeah. But now here's another thing, you guys. Every file that you hand in has to have on the top a comment, 3 comments: name, date, and assignment. Okay? As a programmer, you should, every time you write a program, you should do that with every program you ever write in your whole life from now on to eternity. Okay, so make sure and do that also.
So it's just a number and the name, no period or anything?
Correct. That's important. No period. It's yeah, so it would be for shapemain.cpp, it would be like if your number is 99, it would be 99 shape main dot CPP. Yeah, it would be like this. Yeah.
So add our name in the actual program, like in the code?
In the code,
Yeah, like a comment. just-
yeah, comment at the top. Yeah. Yeah, in the code, add a,
It's already set up. Not like kind of how it is in the other class, but it's already like set up.
yeah, we had that example, we had that
So
example.
Do we just add it to one of them, or every single one?
Every one that you hand in, you should, because you code, if you're responsible for the code in that file, somebody should be able to look at that and see who wrote it and when and what it is. Yeah, that's just a habit that everybody, that all programmers should have, you know. Because, I mean, who knows, 3 or 4 years from now, this file might be floating around, oh, that was an assignment for data structures. I wrote this, here's when I wrote it, you know. It's for posterity. Plus, it's for me because when my program strips off those things, and when we're grading, we need to see who turned it in. Okay? Is everybody clear? Any more questions? All right. Well, then, what let's do now is I think for the rest of the day, if there's no more questions about that, let us go do some code walkthrough and see, because we did the demo, remember when we did the demo of the shape project itself, and you can make a project, you can make a shape and set the dimensions and stuff. So let's go through some of the code for the main program and see how the main program actually works. So here in figure 1.17, is the start of a program of the program listing for this project. Now, what the main program does is it basically does 4 things. It initializes all the data structures, and then it goes into this prompt, this loop, where it prompts and asks, the user for some kind of an action, and then when the user presses quit, then it does some cleanup, and then it exits. All right. So initialize is a function that the main program calls at the beginning to initialize everything, and here the precondition is that shapes 0.cap-1 is allocated. So cap is a variable that the main program passes that determines the capacity of the array. In this case, the capacity is 5 because remember it says 0.4, pick a shape, 0.4, and so the actual parameter is going to be 5 in this example. And so the precondition is that shapes 0.cap-1 is allocated. So what is shapes? What kind of a structure is it, actually? Can you tell, what does a square bracket mean? Yeah, it's an array. So there's an array of shapes. Okay? And the postcondition is that all shapes 0.cap-1 are initialized to the null shape. So that's what initialize does. Okay, we'll see the code in a minute for how it does it. And then the prompt loop, that's what gets called, the main program calls the prompt loop to, prompt the user for all those actions. And so that's a loop to prompt the user with a top-level main prompt. The postcondition is that the user has selected the quit option, because that's what happens, that's how you get out, that's what's true when you exit, is the user pressed quit. Okay, make shape, that was one of the actions, the parameter for make shape is now this is interesting. Look at this, it's a shape star ampersand sh. Now, you guys know the difference between call by value and call by reference in C++, right? Okay, and how do you specify call by reference? With the ampersand. And so if it's without the ampersand, it's call by value. We're going to review this a little bit more next chapter. Okay, so basically what this is doing is it's an A-shaped star called by reference. A star is a pointer, right? A shape star means it's a pointer, so that's a pointer called by reference. We'll talk more about this in a few minutes. And then shape type, what does shape type return? What type does shape type return? A character, a single letter. So remember whenever we said all the prompts were letters and you type a letter? Okay, so it prompts the user for a shape letter, lowercase or uppercase. The post conditions is that it returns the uppercase character, L, R, C, T, or M. So L was what? Line, R was rectangle, C was circle, T was what?
Mystery shape?
Right triangle, M was mystery shape, okay? And then clear shape, again, pointer called by reference. Original SH is deleted and SH is made to the null shape. Print area, we demoed the print area. Print perimeter, we demoed the print perimeter. Scale shape, remember the scale when you guys wanted to scale it up by 200? Okay, so that was the scale, that's the scale shape one, and then display shape. Now, let's take a look at what these parameters are. In some of these, the parameters are SH, that's a single shape, but in some of these, like in initialize, it gets past an array of shapes, all right? So it's either the parameters are either shapes, square bracket, or SH, which is a single shape, SH. And so here in figure 1.18 is a visual depiction of what those parameters are. So in the shapes array, well, let's take a look at part A of the figure. So if the parameter is a single shape, SH, SH is a pointer to an abstract shape. So that cloud represents an abstract shape. Are you with me? Is everybody? Like we saw in the UML diagram, you know, the concrete shapes inherited from the abstract shape. So in part A, that's a visual depiction of parameter SH, which is a pointer to an abstract shape. But then with the other ones, if it's an array of shapes, then you can think of there being a shapes sub 0, which is a pointer to an abstract shape, a shapes sub 1, which is a pointer to an abstract shape, and so on. Right? So everybody, just to get visual about this, are we good? Okay. So this is the main program. This is the whole main program in figure 1.19. So here we start off, we say const int numShapes equals 5. So that numShapes is a constant. If you wanted to run the program with a dozen shapes, you would just change that to 12 and everything would all work. All right? So you don't have to change it in one place. All right? So const int numShapes. And then the second line is a shape star shapes numShapes. Now what is this doing? What is this? A shape star shapes numShapes. What is this doing? Yes, it's allocating an array of abstract shapes.
Is it in free memory? Is that how it works?
Say it again.
Is it in free memory?
Well, it's not doing. The thing of it is that it's not doing a new here, so it's not allocating it from the heap. Okay. So it's an array. It's an array of shapes, right? And then initialize takes this shapes that was allocated here, and it calls the initialize method, which we saw the precondition and postcondition for that. And remember we said that the actual parameter is going to be 5. That's because it's numShapes, right? And then after we initialize, we call the prompt loop, which does all the prompting. And then after the user presses Q, which was the postcondition for prompt loop, and then we return exit success. Exit success is actually, does anybody know what the actual integer value of exit success is? It's actually an integer. Does anybody know? Well, you're really close. Yeah, it's 0. That's not 1, it's 0.
Error is -1, right?
Yeah, error is anything that's not 0.
So it could be positive?
You know, that's a good question. I don't remember if it could be positive or not. I was afraid you were going to ask me that. Can you Google that?
Sure.
Does it? Go to Stack Overflow. Those guys are really good.
Yeah, that's where I'm at right now.
Yeah. So now here's the code for each one of those methods. So we have initialize returns void. So, and what it does is it sets up, now here's where new comes in. It's for int I gets 0, I less than cap, I plus plus, and then shape sub I gets new null shape. So remember that null shape was the one that was the empty one that we initialize everything to. So let's review a little bit what happens when you do new. So when the new operator executes, it does two things. It does two things if there's no constructor involved, but we'll get to that in a minute. So the first thing it does is it allocates storage from the heap for the attributes of the object, and then it returns a pointer to the newly allocated storage. So look, let's go back to figure 119. Here when it says new null shape, what does it do? It allocates storage from the heap, and then it returns the pointer to it. And then shape sub I gets that pointer that got returned by new. Is everybody good? Is this all review? So that's what new does, okay? And then here is the prompt loop. It's basically a do at the top here. This is figure 120. And then at the bottom it's do while to upper response is not equal to Q. So as long as the user doesn't type Q, it's going to keep looping. So this guarantees the post condition, right? Because it's the only way it can quit. Okay? So what it does is it says, first of all, we have a local variable called response, and it's a character. Okay? We just initialize it to the null character. And it says, and we say do, and then here's that prompt. You know, there are 0 dot dot cap minus 1 shapes, so that was 0.4 because cap is 5, right? Shapes, and then end line, start of the next line, and then there's make, clear, area, perimeter, scale, display, quit, and then we do cin response, so that whatever letter you type, that response gets that, and then there is a method called toUpper that converts whether you type uppercase or lowercase, it converts it to upper, and we do a switch on that, so you guys know the switch statement with case, right? Is everybody good? And then, so we switch, and then we case, and now we can do case capital M, capital C, capital A, because we did two upper, see? Okay, so boom, 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 boom. And if it's M, we do make shape. If it's C, we do clear shape. If it's A, we do print area. And furthermore, now, do you remember when we demoed this and we put an integer value that was outside the range? Remember that? And we said what would happen, and somebody said, oh, it would crash, and I said, oh, well, luckily the user, you know, it was programmed so that it wouldn't violate the precondition. Well, what we have is, and you can look these up in the text, in the appendix, or you can actually look in the code of the DP4DS distribution. We have these utility functions that do this range test automatically. So so under make shape it says shapes, I prompt between which shape, and then we give the utility 0 and cap minus 1. So we make it, so this is 0 and this is 4. And what I prompt between does is it will loop through, and if the user types an integer that's out of range, it will ask again, ask again, ask again. And so if you call I prompt between 0 and cap minus 1, the post condition is guaranteed that the value that gets returned by I prompt between is between 0 and 4. And then this whole thing is in the what? Look at this. That whole prompt thing returns an integer, and it is in the what? The brackets of the shapes array. You see how that works? Pretty slick coding, huh? I mean, see, an amateur programmer would have a variable, and by prompting gets that variable, and then would say shape sub that variable. Are you with me? But why? Why have unnecessary variables? Why not just have it all in this expression? Is everybody good with this? All right, and then same thing with clear shapes. Clear shape, shapes, sub, and so shapes sub this is one individual shape. So if you look at if you remember the parameter for make shape, it took a single shape. See? Make shape takes a single shape, not an array of shapes. Are we good? I'm assuming that you guys are all following this all right. And then here is, and so on for the rest of this. And then here is make shape. All right. So let's remember what shape type is. So shape type prompts the user for a shape letter. Right. So when we do make shape, we do switch shape type, so that prompts for a letter, and so we switch on that letter. And if it's L, then you make a line. If it's R, you make a rectangle. If it's C, you make a circle. Blah blah blah. And so let's suppose that the person typed R. So what you do, what make shape does is, remember we said, somebody asked, what happens if you make a shape on top of an old shape? And we said it just replaces it. Well, here's how it replaces it. Okay, so there's make shape. Oh, and here's an exercise for the student. So you have to do this for the mystery shape, your mystery shape. Be creative on your mystery shape. I've had some really interesting ones in the past. You can pick any shape you want, but it needs to work, you know. I mean, don't crash the program can't crash. Okay, and then here's some more code for the shape type. Actually, this is the prompt for the shape type. And now, when the new operator executes on an object that has a constructor, we add an extra step. First, it allocates storage from the heap for the attributes of the object. Then, before it returns the pointer, it calls the constructor based on the number and types of the parameter in the parameter list. So this constructor gets called when you do a new. Is all this review? Yeah? You've done constructors before? And then here's clear shape. The way you clear a shape is you delete SH, and then SH gets new null shape. Here's print area, here's print perimeter, here's scale shape. It's all just etc., etc. And so what this program illustrates is behavior abstraction, where you have several different classes into this one behavior abstraction. Now, what is the key characteristic of behavior abstraction? We'll end with this. What is the key characteristic of behavior abstraction? We mentioned this the other day. Do you remember what it is? It's polymorphic dispatch. Now look, here's where polymorphic dispatch happens. Let's go back one slide. And let's take a look at this print perimeter. Now look at what this print perimeter does. It says it's given, SH is a what? What is the type of SH? It's a pointer to a what? To an abstract shape. It's a pointer to an abstract shape. Now what are we saying here? We're saying cout, new line, perimeter, and we're outputting what? SH arrow what? Perimeter.
Because it's stored at that location.
Well,
Or it's where
well, here's my question. How many perimeters do we have in this whole setup, in this project? We got a perimeter for what? A circle, we got a perimeter for what? A right triangle, we got a perimeter for what? A line, we got a perimeter. Yeah, we got all these different perimeters, right? And they're all called perimeter. But wait, this SH, well, what is the type of SH? Is this a line, or is it a rectangle, or is it a circle? What is it?
Pointer.
Well, I know, but a pointer to what? A circle, a line, a rectangle to what? Because what is the type of SH? It's what? It's abstract. Well, how do we know which one's going to get printed?
Because we said it in May, right?
No. Can you look at the program and tell which one's going to be printed here?
It's based on what the user does.
Yeah, it's based. Yeah, it's what? What is this? It's polymorphic dispatch. You see what we're saying here? That line illustrates polymorphic dispatch. Because why? Because SH has two types. Okay? Now, this is a really important concept, you guys. SH has two types. It has a static type and it has a dynamic type. If the user types R for rectangle, all right, so that SH was a rectangle during runtime, the static type here is A shape. But during runtime, it would be rectangle. The type would be rectangle. Do you see what I'm saying? So an abstract type, a variable that is an abstract type, actually when you run the program has two different types. Static means determined at compile time. Dynamic means determined at execution time. Are you with me? And so what happens is, here we can say in our program sh arrow perimeter and not know which perimeter is going to be executed. Why not? Why can't we know? Because we don't know what the user is going to pick. But whatever the user picks, that will be the dynamic type, and the perimeter that gets executed will depend on this. So look, if you didn't have this, then what would the code inside perimeter have to be? It would have to be, if the shape is a rectangle, then do the rectangle. Else, if the shape is a circle, do the circle. Else, you see? But there's no if. That if is hidden, which means it's what? Abstract. Hiding detail. All right. See you tomorrow.